Hi, good afternoon. Yeah, today, by the way, today is 28th of September 2020, and today is Sunday, and the time now is 12:35 in the afternoon. Yeah, today I'm going to pour concrete on this small area of concrete along boundary wall, and after that, I'm going to pour this retaining wall. So, but before continue doing these activities, I want to show you some sort of presentation how this concrete stability and this retaining wall. So this just like a part of engineering analysis. So when you pour the concrete from the bottom to the top, so the height is 309, and so we need to determine the location of maximum pressure induced by the concrete on this retaining wall. So the location of that is 2/3 of height, which is 2/3 of, so this is height, so multiplied by 309. Yeah, that's the maximum pressure on this concrete, which is 2/3 of the height. So which is, if you calculate that one, so this one is 1, 0, and 3, so which is 2, 0, 6 from the height. So from top to here, as you can see, that is 206 millimeter. So that's the location of maximum pressure on this concrete. The reason I want to show you, because if you're not doing the proper preparation for formworks, when you pour concrete, it will push the concrete on this way, this direction. So you need to be very careful about the bottom. That's why, as you can see, I put some protection here. I put a peg and pegs here, so that I can resist the force induced by the concrete inside this formworks. And that's the maximum pressure is in here. So that's why, as you can see, I put nails in here to resist the pressure of fresh concrete on this area here. Yeah, and also I just leave this open so that when I pour concrete from this top, it will flow. I want to be sure that it flows on this area here, on this cavity. So when the concrete is ready on this level, I'm going to close it with this one. Yeah, that's why I prepared this what do you call that, timber, for this purpose. Yeah, so this is just like a physics subjects. So determining the maximum pressure of concrete on this height. And also the reason why I put these pegs in here, because when you put a load on this retaining wall, so it will push the bottom, it will push the timber on the bottom. And as you know, the weight density of concrete is 150 pounds per cubic foot, which is equivalent to 2,400 kilograms per cubic meter, or 2.4 tons per cubic meter. So that's the weight, the density pushing this timber board. So that's why I put these nails in here to support, to resist the pressure pushing by the concrete on this timber. So it's just like a simple principle of when you push, and sometimes to push back to make it equilibrium, so it becomes zero. So that's a principle of engineering mechanics. The resultant force always zero, so always equilibrium. Alright, I hope you like my short presentation about how this fresh concrete works and this retaining wall. I've seen a lot during my old days when I still working as a civil engineer in construction. There's a lot of some structures, they didn't treat the formworks properly. That's why it collapsed. The concrete pushed the formworks and it collapsed here. So once it collapsed, you can't continue doing it. You need to redo it. Otherwise, it's gonna be messy. Alright, even when I work in marine construction where we pour concrete on the water, the same principle applies. You can pour concrete even in the presence of water. The principle we use is the tremie pipe concrete construction. So that's part of a process in marine construction. Alright, folks, my friends, I hope you like my short presentation. Thank you so much. I'll give you current update once everything's completed. Okay, please be safe and God bless. Bye for now.